Okay, hi, Mr. Hannah here. This video we're going to be talking about intervals. And same with the last couple of videos, and for this entire chapter actually, it's all just about learning lots and lots of new symbols and ways to write things that you can probably already use. So here we go, interval notation. So you probably already know how to write something like x is between A and B. And you probably know that this symbol here means x is greater than or equal to A, and x is also greater than or equal to B. So on a number line, what does that look like? So if here we've got A, here we've got B, means x could be anywhere in there including A or B. So it could be A, so we use a dark circle to say that. It could be B, and it could be anything between them. So we represent like that. Now, if we had the case where it was x is greater than or equal to A, but it's strictly less than B, so this time x cannot be B. Well, the only thing that changes here, A, B, is we still use a filled-in circle for A, but now we use an open circle for B to show that x cannot be B. Now, there's also an alternative notation for intervals, and it's using brackets. Now, we've got a choice between using just regular old parentheses, the circular brackets, or between using these square brackets. Now, these circular brackets basically mean not including, not including, not including, and these square brackets mean including. So here, this one's including A and B, so we say that x could be within the interval A, B, and these represent including. Here in this case, x is within the set. Now we're including A, so we do a square bracket on this side, but we're not including B, so we'll do a circular bracket on that side. So let's do a final example. Let's suppose we've got a number line and it goes from -1 to 4, and these are the symbols. Here we can represent this interval by saying that x is above -1 but not including it, and it's below and 4, or possibly including 4. Or an alternative way to write this is x is within the interval 1, 4, with a curly bracket here and a square bracket here. Okay, now a couple of other extra things that are worth noting when it comes to this interval thing is a few common things, notably if it was said sketch x could be within -infinity to 2, the way we'd write that on the graph is here's 2 and it's not including 2, so we'll do a circle and then an arrow. So negative infinity basically means infinity that goes backwards into the negative region. So where this is. So continuously all the way to as negative as you want. Now notice, negative infinity is not actually a number, it's more of sort of a concept, and so we use the circular bracket to say that x does not include the actual number minus infinity, because that's not really a thing. You can also have a similar thing with positive infinity. Now let me complicate this example a little bit more by putting in a union. So x is within this. Union means or anything from, let's make this a square bracket, in fact, anything from 4 to positive infinity. So again, circular bracket on the positive infinity. Now it says here square bracket, so it's including 4. So a black dot for that, and anything that way. So here we've got a union. Now once again there's an alternative way to write this thing. Because you see this is including just about all the numbers. So you could say, a new way of saying this is x is within the real numbers, in other words, everything on this number line, excluding this set in here. So this set in here is, so it's excluding, so we want it to exclude the number 2, because 2 is not allowed. So we can say excluding the number 2, and it's square brackets because we want to exclude the actual number 2, all the way to the number 4, not including 4. We don't want to exclude the number 4 because it's included on what we've got there. So x is within all the real numbers, excluding the interval from 2, including 2, to 4, not including 4. So there's an alternative way to write that. A couple of very last things are, because it's so common, sometimes we use the notation R plus to basically mean all the real numbers. Maybe I'll do this on a number line. Here's 0, and it goes up here. We use R plus to mean this, so everything larger than 0, not including 0. And we also use R minus to basically be the opposite sort of thing. It means negative numbers, not including 0. So often you will see things like this, R plus, and then union 0. Now that basically means all of the positive numbers, whoops, I skipped 1, all the positive numbers including 0, because we've got the union of 0, so it means anything in R plus or 0. So it's including 0. Okay, to finish this video off, we might do one example. Okay, so here's an example, and we're going to be asked to find the domain and range of this relation here. Let's make one up. The relation of the ordered pair, or the set of ordered pairs x, y, such that y equals x squared plus 3x plus 2, for x being within the set minus 2, 1, including minus 2 and 1. Okay, now the best way to do these is first to graph it, assuming that the domain is actually the real numbers. So here, it actually tells us the domain already. Domain. So we already know the domain. It's this here, the interval between minus 2 and 1. To find the range, it's best if we actually sketch this graph first, and then just cut it off where we need to cut it off. So first we notice we can factorize this to x plus 1 and x plus 2. So that gives us our intercepts on the x-axis of minus 1 and minus 2. We also notice that it's not been reflected, so it's a bit of a smiley face style. And the y-intercept, if we put x in here, is 2. Okay, so now we can quickly do a bit of a sketch of that. Now let's look at the domain. It's only valid for x values between minus 2 and 1. So here's 1. Let's find out what this actually is when x is 1. When x is 1, we've got 1 squared plus 3 plus 2. So 1 squared is 1, so it'll be 1. It'll be 1 plus 3 plus 2, which will be 6. So this point up here, when it's 1, it's going to be 1, 6. So that's that point there. Okay, now we notice if this graph went up, what we'd have to do is get rid of that, and we're going to get rid of this graph here too, that bit, because the only bit that's valid in the domain is when x is minus 2, not for when x is less than minus 2. So put a nice filled in circle there so that we know that it includes that point. Oh, heck. Okay, so now we, to find the range, well, it's going to be whatever this value is here, all the way to this value here. Now I've just realized that because I have not taught you calculus, you don't actually know what this point is going to be. Actually, whoops, that's not true. You know, because quadratic's always symmetrical, that this point of the turning point in x must be halfway between minus 1 and minus 2. So that must be minus 1.5. Minus 1.5 there. So this value here must be minus 1.5 squared plus 3 times minus 1.5 plus 2, which equals no, that 1.5 is actually 3 on 2. It's actually easy to use fractions here. So this becomes 9 on 4 minus 9 on 2 plus 2. Now I'll make all the denominators 4 to make this easy for myself. 9 on 4 minus 18 on 4 plus 8 on 4. Oops, 8 on 4. Equals minus a quarter. There we go. So there is, this one here is minus a quarter. So we have now our bounds goes from minus a quarter to 6. So we can now fully answer the question, say the domain is equal to, so there's two ways to do this. You can say it's equal to minus 2, 1. Or if you had a 1 to 2, you could say the domain is x is within minus 2, 1. And the range, well, because we're including this point here, the range goes from minus a quarter up to 6. And similarly, you could, if you had a 1 to 2, say y is within minus a quarter to 6. So there we go. Example done. See you in class.